Hey guys, welcome to the lesson. Today we'll be looking at AWS Lambda functions. In this tutorial, we'll write two Lambda functions, one to read data from the database and another one to write data back to the database. We'll be using DynamoDB, which, in case you don't know, is an AWS NoSQL database that stores key value pairs, similar to MongoDB or Couchbase, but more on that later. By the end of this lesson, you'll know how to write a Lambda function, how to give it permissions to talk to DynamoDB, and we'll do that via IAM roles, and also how to do some basic testing just to make sure everything works okay. Alright, before we get started, I just want to give a brief overview of AWS Lambda and of serverless computing in general. So, what is Lambda and why do I want to use it? Basically, AWS Lambda is one ingredient in Amazon's overall serverless computing paradigm. And what it does is it allows you just to run code without thinking about servers. In other words, Amazon abstracts away all of the other components that you would normally need to run code, including servers, platforms, virtual machines, and basically anything else, so that you can just focus on writing code and telling it when to run. So, since you don't have to worry about any of those other things, the time to production or time to deployment is very low. You can literally write a Lambda function, configure it, and having it run in production in minutes flat. Another great benefit of using Lambda is that you pay only for the compute time that you consume. This means that you are literally only being charged for the time that your code is actually executing. Now, this is in contrast with a traditional model where you may be paying for servers, updates, maintenance, perhaps even IT personnel, regardless of when your code is running or when it's not running. If we take a quick look at the pricing structure here, we can also see that your first 1 million requests with Lambda are free. And then after that, you're literally paying fractions of a penny on the dollar for any requests after that. So this is a big benefit. It's a very cost-effective way to run code. All right, one other side note on serverless computing. Of course, that doesn't really mean that there's no server involved. Your code is still running on a server somewhere. It's just not your server. It's someone else's server. So actually, you could just as easily call it server-full computing, but you didn't hear that from me. All right, that's enough of that. Let's get coding. All right, so the first thing we want to do here is to go over to DynamoDB and create a simple users table so that we have some data to work with when creating our Lambda functions. Now, of course, you'll need an AWS account to do any of these exercises. So if you don't have one, just head on over to aws.amazon.com. I won't walk through every step of the sign-up process because it's pretty self-explanatory. But you just want to go over here to create a new AWS account and then follow the prompts, fill out all the forms until you've created your new account. Then go ahead and sign in, and that should bring you to the AWS Management Console. So from here, we basically want to go over to the DynamoDB area. So just start to type in Dynamo here. It should pop right up. Just click on that. All right, now before we do anything else, we're going to want to go ahead and select an AWS region from the right-hand side of the top menu here. Now, you're going to want to go ahead and select the geographic region that's closest to your location. For example, I'm in Seattle, Washington, so I'm going to leave US West 2, Oregon selected. And you just want to make sure that, throughout the remainder of these exercises that whether you're working on Dynamo or Lambda or anything else, that you have the correct region selected. All right, so we want to create a table. So click on the Create Table button, and I'm just going to give this the name Users. Partition key, that is just a unique identifier for each entry in the database. So I'm going to use an ID for that. We'll leave that set to string, leave everything else set to the defaults, and click on Create. All right, so it'll take a second or two for our table to be created. And then I think what we'll do is we'll go ahead and add one item in the table so that we've got something there for us to use when we create our first Lambda function. So if you click on the Items tab and then click on Create Item, that should pop up the Create Item dialog. And here's where we can actually add an entry into our database. Now, there are a couple of different views here. This is tree view. I actually like to go here and change it to text view because then it looks more like JSON. It's a little bit easier for me to read this. So you can use either view that you prefer. I'm going to go ahead and set this to 1, 2, 3, 4, 5. And let's see, so whoops, I think we'll do a first name. We'll say Bob, and then let's do a last name as well. And we'll say Johnson. Okay, so once we have that, just click on the Save button, and that will go ahead and add that entry to our table. All right, and that is literally all that we have to do with Dynamo right now. We'll come back here later to check to make sure that our Lambda has actually put values into the table once we get to the writing portion of the tutorial. But for now, that's all we need to do. Okay, so the next step is going to be to create an IAM role to give our Lambda function permissions to work with this DynamoDB table. All right, guys, so before we head over to create our role, there is one more piece of information that we're going to want to get from our DynamoDB table. So if you click on Tables from the left-hand menu and then go ahead and click into our Users table that we just created, you want to look at the Overview tab, and if you scroll all the way to the bottom, you should see the Amazon resource name, or ARN. And what this basically is it's a unique identifier to the Users table, so that we can input this into our role later on so that the role knows which table to provide the permissions for. So let's go ahead and just copy this value here and head over to IAM so we can create our role. So let's click on the Services dropdown. You may see that you already have IAM over to the side, but if not, just start to type it in. It should pop up there for you. So click on IAM. Okay, so we are at the Identity and Access Management landing page here. We want to create a role, so let's click on Roles from the left-hand menu. Now, you guys may have noticed that my screen is much bigger than before. I've blown it up a little bit, so hopefully this is good and you're able to see everything that I'm clicking on and everything that I'm typing into the forms here. So let's create a role. Click on Create Role. Let's leave AWS Service highlighted. This is basically asking us what kind of role do we want to create. And now we want to create a service-to-service role because we want to give our Lambda function permissions to access our DynamoDB table. So click on Lambda, allow Lambda functions to call AWS services on your behalf. And let's click on Next. Okay, so here we want to add a policy. If you start to type into the box AWS Lambda Basic Execution Role, now that should pop up. Here we go. Just put a checkbox by that one and click Next. So tags, these are optional. We're not going to use any tags today, but this may come in handy if you have a larger application where you have lots of roles and you need a better way to organize them or some way to search through them, then you can use tags. So for now, we'll just click on Next. All right, now let's give this role a name. I'm just going to call it Lambda DynamoDB role. And we can see it's got our basic execution role policy already added to it. So let's go ahead and create that role. Okay, now that that role is created, we do want to add one more policy to it. So if you click on the Lambda DynamoDB role, okay, and we're going to click on Add Inline Policy. Now, just expand the service section here. And we're looking for Dynamo. We're going to add permissions to allow this Lambda function to call Dynamo. There it is, so just select DynamoDB. Okay, now in the Actions section, we're specifying actions that are allowed in the DynamoDB database. So we could very easily just click on All Actions right here, star, and just give blanket permissions to access anything or to take any actions against Dynamo. But really, best practice says that you should give the least amount of permissions necessary to fulfill whatever function that you're trying to accomplish. So we're going to need basically get and put permissions. So we can go ahead and click on Add Actions and search for, let's do get item. Okay, and click Add. And there it is, DynamoDB get item. And let's do one more for put item. Okay, and that's been added. Great. Okay, now let's expand the resources section here. Leave it as specific and click on the Add ARN button right here. And here's where we will paste in our copied Amazon resource name for our Dynamo table. And once you paste that in, all this other stuff should populate automatically. So then we can just click on the Add button. Okay, that looks good. And let's see, we don't need to do anything here. So let's just click on Review Policy. All right, let's see. We need a name for our new policy, so let's just say Dynamo read write access. And create policy. Okay, there we go. So our role is all configured and all set and ready to go. And once we get into creating our Lambda functions, we will basically assign this role to our Lambda functions so that they can access the DynamoDB table. All right, so next task will be to actually get in and start coding some Lambda functions. All right, so let's go ahead and click on Services from the top menu and start to type in Lambda into the box here. It should pop right up. There we go. And we are at AWS Lambda. So quick region check, just look up here in the right-hand corner and make sure that the region that you previously selected is still, in fact, selected. I've got US West Oregon, so that looks good to me. And let's go ahead and click on Create a Function. Okay, now as you can see at the top, there are a couple of different options here to get going. We are going to use author from scratch, so just creating a Lambda function from ground up. But you could also potentially create a Lambda function from blueprints, which is a template, or from a shared library or shared repository where you can find Lambdas that have been built by other people. So let's go ahead and leave author from scratch selected, and let's give this function a name. I'm going to say get user Lambda, or let's say get user data. Okay. For the runtime, I'm going to use Node 8.10 because that is the latest version of Node that's currently supported by Lambda. So for role, let's leave choose an existing role selected, and under existing role, we're going to select the Lambda DynamoDB role that we created in the previous exercise. All right, so once you've got those selections made, let's go ahead and click on Create Function. All right, so this is our Lambda IDE, if you will, or the area where we can basically code and configure our Lambda functions. Now this first tab that's collapsed here, called Designer, we can take a quick peek in here. And this is the area where you would just configure different events that may trigger your Lambda. So just to back up a step, basically Lambda functions can run as a response to various events. Some examples of such events may be uploading a file to an S3 bucket, which you can configure here so that your Lambda triggers once that file is uploaded. Once that event is emitted from S3, then your code will run here as a response to that and do any processing that you may have. Your Lambda function can also be called from a REST API. And we'll see that a little bit later in the next video when we wire up our API gateway to trigger our Lambda functions. So we don't really need this for now. Let's go ahead and collapse the Designer tab. Function code, this is what we'll be looking at currently. So there's 3 different ways to get your Lambda code into your Lambda function. First of all, you can see right here, there's some boilerplate code, and we can edit this code directly right here and be done with it. Of course, that works well, in the most trivial situations. If you don't have any external dependencies, you want to just have a very basic Lambda function, then yeah, you might want to just edit it right here. However, if you do have external modules, for example, NPM packages or anything like that, that your code's going to be relying on, then you would want to create your Lambda function outside of this interface, in your own IDE, and then zip up that whole code that whole project basically and upload it here to AWS. And this is just basically the same as the previous option, only you're uploading a file from Amazon S3, from an S3 bucket. So we're going to sort of take a hybrid approach here. I don't want to edit the code directly in here, but I want to create the function outside of AWS in my own IDE, and I use Visual Code. So I want to code the function there, and then I'll just basically copy and paste it here. One other side note on that, we won't have any external dependencies other than the AWS client. Now, you can just assume that you'll always have access to AWS client in your code. That is to say that it exists implicitly, so you don't need to add it, you don't need to install it. You can just import it directly in your Lambda code and assume that it's going to be available. All right, guys, so let's head over to my code editor. Now I use Visual Studio Code. You can use whatever you want, of course. I do highly recommend you check out Visual Studio if you haven't. It just has really good performance, really good plugins, and it's just a really good overall editor. So let me see if I can enlarge this a little bit so you can see better. Okay, hopefully that is okay. All right, now if you do use Visual Code, there is an extension for AWS Lambda that I want to point out. So if you go ahead and click on extensions here, now I've already installed this, but you could just search for AWS Lambda. And what this does is it provides some boilerplate snippets to get you started. So it'll basically scaffold some boilerplate code for an AWS Lambda function. Now let's try this out. And I don't believe you'll have to restart Visual Studio, but if you can't get it to work, you may want to go ahead and do that. Mine's already installed, so I don't want to really uninstall it and go through that again, but let us just take a look and I'll show you how it works. All right, so I've got my project here, AWS Lambda. What I'm going to do is I'm going to create a new folder and call that Get User Data. Now inside that folder, I'm just going to create a file called index.js, and this is going to be basically hold my Lambda code. Now with this extension that I was just talking about, you can type in Lambda, and you see you get some commands popping up already. Now if I do this one, Lambda AWS, see that automatically scaffolds a starting function for me there. So this is a great way to start out. All right, so just a brief word about the anatomy of a Lambda function before we start coding. First off, you'll see that this function is called handler. All right, that is the function that is being exported from this file. And if we pop over to AWS again really quick, we can see that right here. So this Lambda function is being invoked via index.handler, where index is the file name, index.js, and handler is the one function that's being exported from that file. All right, back to Visual Code. Lambda functions take 3 arguments by default: event, context, and callback. The event object contains information about the event that triggered the Lambda. So for example, if this Lambda was triggered by a REST endpoint in API Gateway, then that event object would contain information about the request body, about URL parameters, and other information regarding that request. The context object provides methods and properties that provide information about the invocation, function, and execution environment. And the callback is just a callback method that you're probably familiar with if you've used NodeJS, a callback method that you can return to the calling function that invokes Lambda. All right, we actually won't be using any of these 3, at least initially. So let's go ahead and get rid of this commented out code and this console log and start fresh here. Okay, so you can see our only import here is AWS SDK. First thing we want to do here is make sure the region is set. So we can do aws.config.update. And we want to pass in a region object corresponding to the region that we selected. So in my case, it's US West 2, but make sure this contains whatever region you're using currently in AWS. All right. Now, so the purpose of this function is going to be to retrieve an item from DynamoDB. So let's take a quick look at the DynamoDB API and see how we can do that. All right, so here's some basic description, overview of the AWS.DynamoDB service object. Let's go ahead and search for getItem. All right, so this is the function that we want to use, and we can model our code after this. So once we instantiate the object, then we do .getItem, pass in params, and a callback function. So the first thing we want to do, we want to instantiate an instance of the DynamoDB service object. So let's do new AWS.DynamoDB. And this API version is just kind of a standard object that's used to instantiate various AWS service objects. So this is a standard format, so this can be passed in as is. I believe there's only one API version. All right, now we can start to construct our parameter object. So this object is going to basically describe the item that we want to pull out of DynamoDB. So first we want to specify the table name. It's the users table. All right, and then we want to specify a key, which I don't know if you remember earlier, we talked about the primary key for our users table, which was ID. All right, so we want to set ID. And so DynamoDB uses a sort of special flavor of JSON called DynamoDB JSON. And it looks similar to regular standard JSON, except values are actually prefaced with a key value, in this case S, which describes the type. All right. So we're gonna, a little bit later, we're gonna look at a way to unmarshal this DynamoDB JSON to more standard JSON, so we can use it, so it's a little bit more predictable and familiar when we're using it with our REST API. All right, but for now, we'll just use the DynamoDB JSON as is. All right, now that we've got our params object, we can go ahead and write our getItem function. So DDB getItem, and we'll pass in params, and we'll pass in our callback function. All right, so we'll check for our error first, and if there's an error, we'll just say console.log. All right, and if we do get our data back, then we'll just console log that as well. All right, and again, you'll notice that we're not using callback because we're just going to test this function directly from Lambda, so there's no calling agent that a callback could be passed to. So we're not using any of these arguments right now. All right, so I think we'll go ahead and save this. Now we can go ahead and copy all of this code, and we're going to paste it into Lambda. So go ahead and Control-C, copy that, and let's go back over to the AWS console, back over to Lambda, and we can just replace our existing Lambda code with the code that we just wrote. All right. Oh, it doesn't like something here. This should be all caps. There we go. All right, now you can go ahead and save that. Okay, and I think I need to make my screen a little bit bigger here. Let's see. Come on. There we go. Okay, maybe that's a little bit too big. There we go. All right, so now we're ready to do a quick test of our function. So what we want to do is head over here, and what we need to do is configure what's called a test event. So if you just expand this dropdown, click on Configure Test Events. We want to create a new test event, so let's call this one Get User Data, same as our Lambda function. Now, the way this works is basically you can provide arguments here, or you can provide a JSON object that would mimic, for example, your event object that would normally be provided, by means of invoking your Lambda function from a REST API. Since we're not doing that, we really don't need to provide anything here, so we're just going to leave it as is and click Create. Okay, Now let's go ahead and click on the test button and test out our Lambda function. All right, execution results succeeded. So that looks good. And we can see right here, here is our object from our DynamoDB. So Bob Johnson, 12345, that was successful. So our Lambda function is working. All right. All right, now that we know our Lambda function is working, there are a couple of things I want to do to improve it. So let's head back to the code editor. Okay, now if you remember earlier, I mentioned this kind of funky DynamoDB JSON syntax. We want to get rid of this. We don't want to have to deal with types in our keys, especially when this JSON comes back to our application. We don't want to have to actually do ID.s to get this value. We just want to do ID, right? So in order to do that, we can use something called document client, and this is going to unmarshal our DynamoDB JSON to more standard JSON. All right, so right under your DDB service object, what we can do is create a new variable, constant, and let's do document client. Okay. So we're going to do new AWS.DynamoDB .document client. And again, I'm just going to pass in the region like I did here. All right, now that we've got our document client, what we're going to do, we're actually going to invoke getItem via the document client and not the DynamoDB service object. So let's copy and paste our variable name here. And the syntax is slightly different if you're using document client. So instead of getItem, it's just going to be get. All right. Now the only other change we'll need to make is we can go ahead and get rid of this string syntax here. And we're going to do key. Oops. Put ID directly under key like that. Okay, let's bring that back here. All right, I think that looks pretty good. So let's go ahead and copy this code. Save this file. We'll copy this back into AWS, and we'll see if this works. All right, so just scroll down here to our Lambda. I'm going to do Control-Alt-Delete and just copy this code here. Oh, you know what? I fixed this in AWS, but not in my code editor. So I've got to remember to fix that. That should be all caps. All right, and let's save it. All right, and we can use the same test event as before. So let's just go ahead and hit test. That looks good, succeeded. So let's see. And that looks much better. So we can see our item it looks now like more traditional JSON syntax. We don't have that weird S key value anymore. So this will be good for use with our actual application. All right, there's one more thing I want to do to improve our Lambda function. And if you remember, when we first created our function, we were using the Node 8.10 execution environment, which means we can use fun stuff like async await instead of a traditional callback. So we're going to refactor our code to use async await. All right, let's head on back over to the editor. So what we want to do now is to refactor this older callback style function to use a more modern async await. Now, since we're using the Node 8.10 runtime, we're able to take advantage of a little bit of magic that happens with the AWS SDK. So what it'll do is the AWS SDK will basically check for a globally defined promise function. And if it finds it, it will add the promise utility method to all of the AWS request objects. So we can basically call this this promise utility method on any of our request objects, such as getItem or putItem, in order to promisify it so that we can then use async await. Okay, so the first thing we can do is get rid of this callback. We won't be needing that anymore. So go ahead and get rid of that. And we can also get rid of this function keyword here. Now let's add async, all right? And we'll just use an arrow function here. So now handler is an asynchronous function. And we can refactor this bottom part here where we do getItem to use await. All right, so we use try catches with async await. Catch, and we'll take an error. Okay. All right, so we can basically take this part, put it up here in our try. Now we want to make this a variable so that we can capture the data coming back. So we'll say const data equals await document client get params. We get rid of this last part here because that's part of the callback style. So now we can do .promise just like that. Now underneath that is where we can put our console log for data. So go ahead and copy, paste, or paste that console log data right here like that. Okay, we can get rid of this old error handling code as well. All right, just clean up my brackets here a little bit. And under the catch error, I think we'll just console log that as well. Console log error. Okay, that looks good. So now our function has been refactored to use async await, and let's see if this works. So let's go ahead and copy all of this code. I'll go ahead and save that. And let's pop back over to AWS. I'll collapse this and go down here. I'll do Control-A, delete, and I'll paste my new code in there. And again, boy, I'm never going to learn. All right, this should be all caps. There we go. I thought I corrected that in the code editor. No, I didn't. There, I'll fix that here once and for all. All right, back over to Lambda, and let's make sure this is saved, and we'll go ahead and test out this newly refactored function. So again, we can use our same event data, or our same test event, and just hit the test button. Succeeded, that looks good. So let's pop this open. And there we go. Getting the same result as before, so that is good with our newly refactored function. Everything is working perfectly. All right, so from here, where do we go? Our next task is going to be to create another Lambda. The next one should go much more quickly because we'll basically copy and paste our get item Lambda function and just change a few things so that it does a put instead of a get. So then we'll be able to test putting items into our database. All right, so what we want to do now is to create a second Lambda function for put user data. So let's go back up to, let's see, the functions level should do it. Yep, okay, and let's click on create function. Now we're going to do the exact same thing that we did before, except this time we'll name it put user data. Okay, NodeJS 8.10, choose existing role, and again we'll select our Lambda DynamoDB role and click create function. Okay, so that looks good. There's our boilerplate code, and let's go back over to the editor. So I think what I want to do here is to create another folder as well to hold our index.js for our new Lambda. So let me click on my parent folder here, new folder, and we'll do put user data. Okay, and I'll create a new file, index.js. All right, so to start out, let's go back to our get user data function. Let's just copy all this code and paste it into our new function. All right, because we don't want to reinvent the wheel. A lot of this code is going to be reused. In fact, most of it. So we can go ahead and save that. Now, let's see. Now, what do we have to change in order to make this put an item rather than get? So, all right, let's look at our params. So where before we were just getting by ID, this time we're actually going to be specifying all the fields that we want to add. So we had first name and last name. Let's do first name. And let's just put any name here. Jennifer. And let's do a last name. White. That sounds made up, doesn't it? Well, good. All right, and then the only other thing I think we have to change is this get, and we'll change that to, drum roll, put. Okay, so with those two simple changes, let's see if this will actually add this item to our database. So go ahead and save that, and let's copy all. Oops, Select all copy, and let's go back to Lambda. Go ahead and get rid of this boilerplate code, and let's paste our new code in there. Okay, let's go ahead and save it. Now we will have to configure a new test event, so just pop this open, configure test events. Again, we can just put user data, same name as our function. Leave the keys alone, that's fine. Click on create, and click on test. All right, success, that looks good. Let's check the details. Let's see, so there was an error message coming back from Dynamo, missing required key item in params. Item in params. Let's go back to our code and see what could be the problem. I see the problem. So this needs to be item instead of key because we're putting, not getting. Okay, so let's just save that. And again, these kind of details you can just find from the Amazon SDK for DynamoDB. That's where I got all of this data from, or that's how I, figured out what kind of syntax was necessary, how this params object was constructed, and what methods to call and so forth. So all that info is in there. Now let's just go ahead and select all copy. Let's go back over to Lambda. Okay, we can close this up for now, and let's replace our function again with that corrected code. Let's save it and hit the test button. All right, let's check our logs to make sure that went through okay. And okay, so I'm not seeing any errors. I'm seeing a null here. I think that's because we're not returning anything from our function. Let me check. Console log data. Okay, so there's probably nothing being returned here, whereas when we were getting an item from DynamoDB before, the item that we retrieved would be in this data object, where with putting, there's really nothing returned. So I'll tell you what we can do now. I believe it succeeded, but let's check our database and make sure. So we should be able to find that new entry with Jennifer White. So what I'll do here, let's pop open this drop down, and you should see DynamoDB since we were just in there. I'll open this in a new tab just so that I have Lambda and Dynamo both open. All right, so let's click on tables. Let's click on our users table. Let's click on items. And there's our Jennifer White item. 1, 2, 3, 4, 5. Oh, do you guys see what happened here? So, yeah, I made a mistake here. So instead of creating a new item, we overwrote the pre-existing item because I used the same ID. I'm sure you guys probably saw this as I was doing it. All right, so let's go ahead and leave this. I'll tell you what we'll do. Let's change our Lambda function so that we specify a new ID and a new name, and we'll just make sure that that gets added. All right, so let's hop back over to Visual Code. I should have noticed that when I was first doing it. All right, so let's do 67890. And let's change, well, let's just change this back to Bob Johnson. So he just got a new ID now. His ID's been stolen by another person. Okay, so we're going to save that. Let's go ahead and select all, copy. Okay, let's go back to Lambda. Lambda, there we are. Let's go back into our put user data function. And let's just copy paste this in here. Let's clear this one out, put the new one in, save it. And let's test this one out. Okay, I don't need to check the logs because I'm pretty sure it's going to do the same thing it did before. Let's pop on back over to Dynamo. Let us, you see this refresh button here over on the right? Click that and that should refresh our results. And there we go. So yeah, that was my mistake earlier. I just specified the same ID, which I didn't mean to do, but that was good anyway, that you guys could see how that works. So now we've got a new ID and we've got a new entry. So that just kind of proves the concept that the ID needs to be unique. So what lesson have we learned today? If we try to put an item with the same ID as an existing item, that item is going to get overwritten. But anyway, this is good. So both of our Lambda functions are working. We're able to put data back into the database, and it's all working as expected. One more quick test we can do, we can go back to our get function. We can change it to this ID and just make sure that we're able to retrieve this one as well. So let's just do that really quick. Well, I'll just type this in, 67890. So go back to our functions. Let's go back into the get user data. Okay. And we'll just modify this code directly right in here, 67890. So this should get our new item that we just added. All right, save, test. And let's check our logs. And there we go, Bob Johnson with the new updated ID. So that is still working. Our changes are backwards compatible. It passed the regression test. And all is looking good. All right, guys, I want to thank you all for joining today's lesson. I hope it was helpful. I hope you learned something. And I hope my explanations were clear enough. But if you have any questions or if you got stuck anywhere along the way, please leave comments and I will do my best to help you out. So again, thanks for joining. I also have a new Udemy course in the works right now, which is building and deploying an entire serverless app from start to finish. So look for that, and once that's available, which I believe it should be February of 2019, I will add that link in the description below. So again, thanks a lot, guys, for joining, and have a great day.